Hello everyone, welcome to today's Moldex3D technical forum. My name is Marcus Su, account manager of Moldex3D EMEA team. Today we are going to talk about the key to run viscoelastic annealing analysis. First, what is annealing? So in general molding process, residual stress may still remain in the product. So annealing is to heat the molded plastic part to just below the glass transition temperature. So annealing is used to reduce inherent stresses, which may be introduced during the molding and also cooling process. In Moldex3D stress, there are two types of annealing analysis. The first is the linear annealing analysis, and the second is viscoelastic annealing analysis. What's the difference of these two annealing analyses? So the first one, linear annealing analysis, we are using the just Hooke's law to simulate the annealing behavior. To more realistic simulation, we should consider the also viscoelastic behavior. So the second method, the viscoelastic annealing, is using the generalized Maxwell model and the WLF model. So this one is to consider the residual stress. So the stress will be released during the annealing. So these two models is to consider how much residual stress will be released. And today we are focused on this how to do a viscoelastic annealing. Okay, so here is a Reddit part, and okay, let's go to see. First, we need to check the material data because in the current R16 we have support this viscoelastic material property and also the structure viscoelastic. And this one is important because when consider annealing, we need the data of viscoelasticity in the solid stage. So first is to check, the material has these two property, and then let's go to the computation parameter. Here you can see, okay, first here's a residual stress. Basically, the residual stress has two parts. First is because the flow-induced residual stress. This is during the injection because the high speed flow rate, molecular is be strength, but when this cool down is not able to relax. So this one is the residual stress for the flow induced. So you need to estimate in filling and packing, also cooling. And then to the warpage, here you need to consider this one, flow induced residual stress in warpage as well. So that's the flow induced residual stress from flow, pack, cool will be considered in the warp. In general, because the general speed, the flow induced residual stress is not so significant. And mostly the effect of residual stress is from the part cool down. So this one to consider viscoelastic material property in warpage analysis. So this one, it will consider the viscoelastic from warpage. So which means doing the warpage, how much shrink, and some of them will become the residual stress. This option is to enable this in warpage. Because the annealing analysis is follow the data from warpage, end of warpage, so we need to make sure the data before the input from warpage from flow pack is what we need, and then to the stress tab you can choose this one. The stress is for the general stress analysis, and we need the annealing here. So you will see the stress boundary condition setting as well. This one, because if you are not setting any boundary condition, there might be sometimes rigid body movement will happen in the analysis. So you will result a divergence analysis. So sometimes you need to pick some node to fix the boundary condition. And next one, to the annealing calculation setting here. Yeah, first, the most important is this one. Consider viscoelastic material property in stress analysis. So when we choose this option, which means from the warpage to annealing, annealing will consider the viscoelastic as well. So this is the whole workflow we need to make sure from the filling, packing, cooling, warpage till annealing. So once you are going to run the viscoelastic annealing, you need the data from viscoelastic data from warpage. Okay, so for the setting, initial temperature, annealing time, and okay, maybe here annealing time, I make some change, and heat transfer coefficient, I'll keep the default value here, and the profile of ambient temperature versus time. Okay, so here is your temperature profile. For example, I can make it like 0 to 60 seconds, 540 seconds. The temperature from 25 to 120. Okay, so the profile will be from the first 60 seconds heat up to 120 degree, then the last minute will cool down to the room temperature. Okay, so this is an important the information here, because the ambient temperature setting is related to the output time step. So right now the temperature difference exceed recommend value 25 degree between each time step is detected. So you can click yes to automatically divide the corresponding time step, or no to keep the current setting. Okay, no to keep current setting. Okay, so because here is a multiple time step output setting, basically in default there are 3 steps. So which means the first time step 45 seconds, and this is just the default segment, but this segment is more than 25 degree difference in this time, because we know our profile, so we need a more segment here. Okay, and we can see if we click yes, what's the difference in the multiple time step. Okay, so for the first 60 seconds, there will be one, three segment. So it will automatically, make the 3 segment for the time step, and also the last from 540, 560, 580. Okay, Because this is a viscoelastic analysis, so we need carefully for the each time step. If the temperature change is too much, the analysis will be not converge. So this is what's the setting where if we are going to do a viscoelastic annealing. Okay, so I have a Reddit result here, and this profile is just I set okay, this one. So 600 second, first 60 second heat up, and last 60-second cool down. And also in this case, I give some boundary condition. Okay, it's here fix the z direction, and also here. Okay, because sometimes if you fix too much boundary condition, the part cannot move, and it still need to deform due to the annealing process. So it will generate extra stress because some fixed position. Therefore, I try to minimize the fixed boundary condition. Not all three, but some of them is fixed. This is to help the stress solver converged. Okay, so we can see first, because the annealing start from the end of warpage. So we can see first, I will turn off unnecessary part. Yeah. Okay, so this is the total warpage, 0.924. And if we go to the end of annealing, total displacement, okay, let's try to make them at the same range, so you can see most of the deformation is decreased, not very much, but slightly decrease because the stress is released. Okay, and also for the misses stress, this is the start because this part is it's the insert. It's a metal ring insert. So there's some different different deformation. Some constraint between this interface, and also here is the both the structure generates some okay, I should check the warpage stress first. It's 131 megapascal. Some is just the boundary value around this interface. And if we go to the annealing vomitis stress, use the same range, we can see most of the stress has been released. Still just some still around the interface, around the structure. Okay, this is the topic today, how we do the viscoelastic annealing. And if you have any question, you can send to the support.eu@moldex3d.com. Hope to see you again. Don't forget to subscribe. Thank you. Bye bye.